You know that what do you mean by an ARM processor? ARM actually stands for Advanced Risk Machine. So that means it uses a basic concept of a risk, and they have made some changes to the basic risk architecture that will meet the uh, requirement of an embedded system, such as overall performance and the power consumption. So it is a new instruction set architecture that the ARM core uses risk architecture, simple but powerful instruction that execute within a single cycle at high clock speed. This is one of the important feature of an ARM processor. It has a fixed length instructions, powerful instructions. They will execute in a single cycle. So at a high clock frequency, as we know that if you operate your microprocessor or a processor controller with the high frequency, you can achieve a you can execute more number of instruction. So overall performance of the system will be increases. But when you operate at a higher frequency, so there is a chances of increasing power consumption. So in general, as we know that when you run fast, so you need more energy like that. So when you operate your microprocessor or a controller at a higher clock frequency, it consumes more power because it executes more instructions, so in a less time. So it has to be balanced, that is the performance as well as the power consumption. So in order to meet these requirements, ARM instructions has been designed using a basic risk concept. So here they concentrate on reducing the complexity of the instruction performed by the hardware, because it is easy to provide a greater flexibility and intelligence in software rather than hardware. That means in order to reduce the overall processor complexity, they reduce the instruction set architecture, so that they included only limited instructions. They execute in a single cycle, and also consumes very less power. So as the circuit hardware complexity reduces, the size of the processor also becomes smaller, and the cost also will reduces. And also we have to compromise with this hardware reduced concept, because as the hardware complexity reduces, the software complexity increases. That means whatever the operations you could not do in the hardware, that has to be implemented with the software. So obviously in case of ARM processor, the software complexity will be increases. So as I told that risk design places a greater demand on compiler. So compiler, you know that compiler is a computer program that translate high level programs into machine language. So it is a software. So in case of CISC system, we have a more complex instructions and a large instruction set, so that which reduces the design complexity of a compiler. Whereas in the RISC system, we have a limited instructions, so that it requires or it demands a more complex compiler. So this is the important point you have to remember. In case of CISC, designing a compiler become easier because it has a more complicated hardware circuit for a complex operations. Whereas in RISC system, we have a less number of less complicated instructions. Because of that one, you need a sophisticated compiler. So that's why the complexity of the compiler will be more in case of a RISC system. So another important feature of a RISC system is that the instructions reduce number of instructions classes. So compared to the CISC system, already you have studied 8086 microprocessor, which is an example for a CISC system. So it has a large instruction set and supports various addressing modes. That is, you can specify the data in various way for these instructions. So which reduces the complexity of the software. So here, in case of RISC system, we'll have a limited instruction set. So simple, that means they provide the instructions for simple operations that can be executed in a single cycle. The compiler or a programmer, he has to synthesize complicated operations. For example, if you want to perform a division operation, in some RISC system, you won't have a division instruction. So that division operation has to be performed using the subtract instruction, so that you have to implement the division operation in the software. So this is the responsibility of the programmer and the compiler designer. So he has to synthesize the complicated operation, and you need to implement that in the software. Each instruction is of fixed length to allow the pipeline to fetch future instruction before decoding the current instruction. So this RISC feature or a fixed length instructions will help to minimize the or easier the implementation of a pipeline concept. That means, as we know that instruction pipeline will help the increasing the performance of a system. So as we know that how actually processor or controller are going to work, any processor basic operation is to read the instruction from memory, decode it, and execute it. So this is the basic concept of any processor, from basic processor to the today's modern processor. So if you take any processor, this is a basic operation that will be performed by any controller or a processor when it is powered on. So instructions will be in the memory that has to be taken into the processor. Then that instruction has to be decoded. That means they have to understand, that processor need to understand that what operation has to be done for that instruction. After that, that instruction will be executed by the processing unit. So this is the way that microprocessor or controller will work. So this operation will be implemented in a concept called instruction pipelining. So they separated this process, that is the instruction fetch, decode, and execution, separate processing unit. So all these units will work simultaneously, so which reduces the overall time required to execute the instruction. So the implementation of this pipeline concept become easier if you have a fixed length instruction, so that while current instruction is executing, next instruction can be decoded in the decode unit, and the third instruction that can be fetched by the fetch unit, so that while the current instruction is being executed, the next instruction will be already ready to execute in the processor, so that it will take very less time to execute that instruction. So the concept of implementing instruction pipeline in RISC system become easier because of fixed length instructions. So suppose if in case of if instructions of a processor is having a variable length, that means, for example, if the processor instruction is of 64-bit, so in that case, that instruction has to be fetched 2 times because that instruction length is 64-bit. So in case of ARM processor, this is a 32-bit processor, all the instructions are 32-bit wide. So when instruction is 64-bit wide, it has to be, it will take 2 cycles to fetch that instruction. So the concept of instruction pipeline implementation become more complex in case of a variable instructions. So that will take a more time. So if you have a fixed length instruction, almost all the instructions will take the same amount of time. So that means you can make sure that all the instruction can be executed in a single cycle. So this is the concept already I have explained, that is what is pipelining. The processing of an instruction is broken into smaller unit that can be executed in parallelly by pipeline. So ideally the pipeline advances by 1 step on each cycle for maximum throughput. So maximum throughput means you have to execute a more number of instruction in a shorter time. So instructions can be decoded in one pipeline stage. Here is no need an instruction to be executed by mini program called microcode as on CISC processors. So usually in the CISC system, there is a special set of program will be inside the processor chip that is called as a microcodes. So you here in this RISC system, you no need that microcodes. So already all the instructions are of fixed length, so that this instruction pipelining will usually in basic system, it is divided into 3 stages: instruction fetch, decode, and execution. So fetch, it will read the instruction from memory, and that will be passed to the decode unit. So decode unit decode that instruction and will understand what operation has to be performed. Then it will pass the instruction to the execution unit. So all these processes will be executed in one cycle. So for first instruction execution, it will take 3 cycles. After execution of first instruction, each ARM instructions will be executed in a single cycle. So because while first instruction is executing, second instruction will be decoded, and the third instruction will be in the fetch unit. So after execution of first instruction, second instruction will be transferred to the immediately transfer to the execution unit, so that after execution of a first instruction, next cycle, immediately in the next cycle, second instruction will be executed. So the process will become faster. So suppose if you won't have an instruction pipeline, means in this microprocessors, each instruction will take 3 cycles, because it has to perform 3 operations: fetching, decoding, and execution. So that time will be reduced. So only in ideal case, that is, the pipeline advances 1 step on each cycle for maximum throughput. So I will explain about that pipeline concept in the next coming class. So at this moment, you just remember that because of that risk concept, implementation of instruction pipelining become easier in the ARM processor. So another important feature of a RISC system is that they have a large register set. So RISC machines have a large general purpose registers. Any register can contain either data or an address. So register act as the fast local memory store for all data processing operations. So this is the one of the most important feature of a RISC system. As we know that, what do you mean by register? Register is nothing but a temporary storage location. So which is like a memory, but it has a very fast access time. So that means it has a very less time to access the data, that is storing a data to the register, and taking the data from register to the processing unit will become faster compared to the taking a data from memory into the processing unit. So this is the advantage of having a large register set inside the processor. But you cannot have a larger register set inside your processor, because it take a more space on that chip. So it has to be balanced. So there should be, as the size of the chip will increases, that will lead to uh, that will increases the cost of the chip, as well as the size, and even that may lead to the more power consumption. So it should be balanced. So in case of this RISC system, they have reduced the number of instructions, but they have increased the number of registers, internal registers, so that the whatever the data that will be processed by this RISC system, that can be temporarily placed on these internal registers, so that they have a very less very shorter access time, so that the processing become faster. So here in this RISC system, another important point is that register can contain either data or a address. So here all the registers, most of the registers will act as a general purpose registers. So either you can store the data as well as the address on these registers. So already you have studied 8086 microprocessor. So in that my 8086 microprocessor, you just have only 4 general purpose register: AX, BX, CX, and TX register. So these are the only 4 register that can be used for data processing. So there are other special registers like SI, DI, SP, DP, BP, like that. These register act as a pointer registers. These index and pointer register only used for the storing the address. So there is a restrictions on the registered usage on the CISC system. So and also they have a very less number of instructions. But here in this case of RISC system, we have a large general purpose registers. So you can use any registers for storing either data or address. You don't need to use worry about which register has to be used for the pointing the memory location, or which register has to be used for storing the data. So you can use any register for data as well as for the address purpose. So this is a contrast to the CISC processor have a dedicated register for specific purpose, as I explained about 8086 processor. So here you have a 4 general purpose registers, 2 index registers, 2 pointer registers. So they have a fixed purpose. So only that purpose you have to use those registers. And also in case of that multiplication and division operations, so always that result will be placed in the accumulator. So AX register and DX register, that is already fixed. So here in this RISC system, there is no such restriction. You can use any register as a destination for any operation. So this is the one of the important feature of a RISC system. So next point is load store architecture. So load store architecture means the processor operates on a data held in register. So that means here in this RISC system, data only processed which is in the registers. So if you want to process any data, that has to be in the register. Suppose if the data is in the memory, that data has to be bring back into the internal register, then only you can process. After processing only you can send the data back to the memory. So this is the way this RISC system will work. So whereas in the CISC system, there is no such restrictions. You can use any register or any memory location directly in the instructions. So for example, you can use the instruction in 8086 processor, that is add AX comma content of SI, like that. So that instruction will perform the addition of a data which is in the register, another data in the memory location. So but here in this RISC system, such operations are not possible because this is a load store type of architecture. So whichever the data you want to process, that should be in the register only. So register idre matra ನೀವು ಅದನ್ನ process ಮಾಡಬಹುದು RISC system ಅಲ್ಲಿ. So separate load and stored instructions transfer the data between register bank and the external memory. Here, because this is a load store type of architecture, they have provided that two separate instruction that will load the data from memory to the internal register, and there is an instruction that will store the data which is in registered back to the memory. There is a separate instructions in the instruction set of a RISC system. So then memory access are costly. So separating memory access from data processing provides an advantage because you can use data items held in the register bank multiple times without needing multiple memory access. So as I told that registers are inside the processor, memory will be connected externally to the processing unit, so that the access time of a memory will be higher compared to the access time of a register. So that this load store, restricted load store architecture, whichever the data you repeatedly use, that can be placed in the register. So whenever that data is not going to be used, you can transfer that data back into the memory. So this will allow the processor to improve its performance. So there is some drawback as well. So because of this load store architecture, sometimes data, if you want data you want to process, that is not available in, if it is not available in the internal register, you have to remove some of the data in the internal register. Some of the already used register has to be overwritten for special data, or whichever data if you want to access from the memory. So this will take the more time. So this feature is contrast to the CISC system, that is design a data processing operation can act on a memory directly. So in CISC system, there is an instruction, they can process the data directly which is on the memory. So that feature is not possible with the RISC system. So this design will allow the RISC processor to be simple, and thus the core can operate at higher clock frequency. So because of all these features, so this will allow the RISC processor to be operated at a higher clock frequency because we have a less number of instructions. So obviously the instruction set circuit will be very small. So it will occupy very low space on the silicon chip, and we have a register set. So there is a separate instructions, so they will perform the operations. They will load the data from memory into the register and register to the memory. So the complexity of the processor will become simple. Because of that one, you can operate that RISC system at a higher clock frequency. So that hardware complexity is very less in case of a RISC system. So this is a contrast to the traditional CISC processors. So they use a more complex operations at lower clock frequency. So they have a large instruction set. So these instructions will perform a complex operations. You can process the data which is in the memory directly, and there are instructions they will perform multiple operations as well. So next we will see the how actually ARM processor has designed. So what we have discussed so far, which is the features of any RISC system. So as I told that this ARM processor is a advanced RISC machine. So as the name indicate that it has a RISC feature, advanced RISC feature. That means it uses a basic RISC feature and make some adjustment so that it will meet the requirement of a a modern electronic systems. So that is the reason for designing an ARM processor is that reduced power consumption. The first important point or a reason for designing an ARM processor is the reduction of a power consumption by the uh, processor that is going to be used in the embedded application. So especially for portable embedded system requires some form of battery power. So the power consumption will become an important point. So as we know that embedded system is a small computer system, so which uses a microprocessor or controller as a central processing unit, so that if it is a portable device, it should be operated only with the battery power. So in such system, you have to select the processing unit so that consumes very less power. So next thing is the high code density. So this is another major requirement. So as we know that embedded systems have a limited memory due to the cost and physical size restrictions. So embedded system means it is a smaller computer system. It may be a standalone unit or it may be a part of another larger system. So that when it is a part of another system, so there is a restrictions on the space as well as the size of the that device, embedded small computer system. So in that case, you have to use a smaller memory in the circuit system. So in the such system, your processor should have a high code density so that you can place a more complex program on a very less memory. So this is the another main requirement of a designing of an ARM processor. That is in order to put a more complex software on a where lesser memory requirement. And another important point is a cost. So embedded systems are price sensitive and uses low and low cost memory devices. So this is the another reason for designing an ARM processor. So ಒಂದು ARM processor ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಸಿಂಪಲ್ ಇರುತ್ತೆ. ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಸಿಂಪಲ್ ಇರೋದ್ರಿಂದ ಹಾರ್ಡ್ವೇರ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಸೊ ಅಂದ್ರೆ ಆ ಪ್ರೊಸೆಸರ್ ಚಿಪ್ ಒಳಗಡೆ ಸ್ಪೇಸ್ ಏನಿದೆ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಸೆಟ್ ನ ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡೋದಕ್ಕೆ ಅದು ಕಮ್ಮಿ ತಗೊಳುತ್ತೆ. ಸೊ ಮತ್ತೆ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಎಲ್ಲ ಹೈ ಕೋಡ್ ಡೆನ್ಸಿಟಿ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಆಗಿರೋದ್ರಿಂದ ಸೊ ಅದಕ್ಕೆ ಸಾಫ್ಟ್ವೇರ್ ಡಿಸೈನ್ ಮಾಡಿದಾಗ ಸೊ ಆ ಸಾಫ್ಟ್ವೇರ್ ಇಂದ ಜನರೇಟ್ ಆಗೋ ಕೋಡ್ ಏನಿದೆ ಅದು ಸೊ ಕಮ್ಮಿ ಸ್ಪೇಸ್ ಅಲ್ಲೇ ಅದನ್ನ ಸ್ಟೋರ್ ಮಾಡಬಹುದು. ಸೊ ನಿಮ್ಗೆ ಆ ಸಿಲಿಕಾನ್ ಚಿಪ್ ಅಲ್ಲಿ ಸ್ಪೇಸ್ ಕಮ್ಮಿ ಆಯ್ತು ಅಂದ್ರೆ ಸೈಜ್ ಕಮ್ಮಿ ಆದಷ್ಟು ಕಾಸ್ಟ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಸೊ ವೆನ್ ಯು ಸ್ಟಡಿ ದ VLSI paper, you will understand that how important it is the very small micrometers or very small nanometers placed on the silicon chip. So obviously, if your hardware complexity on the chip will reduces, that will reduces the cost of the chip as well. So and also because of that reduced instruction in this ARM processor, you can add another hardware requirement that is necessity for designing the system around that processor. So another important point requirement is to reduce the area of the die taken up by the embedded processor. So for a single chip solution, the smaller the area used by the embedded processor, the more available space for specialized peripherals. So this in turn reduces the cost of the design and manufacturing, since fewer discrete chips are required for the end product. So as I told that we have this ARM processing core will require a very small space on the silicon chip. So remaining space can be used for another necessary hardware that is required to design the system around that processing core. So this will simplify the circuit design of or a design of a system around that ARM processor, and also which reduces the cost because it requires a fewer discrete components. After designing a chip, only few external components can be attached to that processor, so that designing of that system around that ARM processor become easier in the designing of an end product. So another important feature of an ARM is that ARM has a incorporated hardware debug technology within the processor. Software engineers can view that what is happening while the processor is executing code. So what do you mean by debugging? So debugging means identifying any faults in your system software. So when your system is running, so if anything goes wrong inside your processor, any data is misplaced or mishandled. So uh, if you are not getting any, if you are not getting any proper results from your system, so in that case, you have to debug your program or your software and how actually data is flowing inside your system. So that can be uh, done by the software. Here in this ARM processor, they have included a hardware debugging unit so that the software designer or the programmer can directly view the how actually data will flow inside the ARM processor with the help of that hardware debugging technology. So after designing a software, you will dump the software into your system memory. So you will start your system to operate. So when your system is operating, when your system is running your software, you can view how actually data is flowing inside the register and between memory and various IO devices that is attached to your processing core with the help of that debug unit. So which with this built-in hardware debugger which has a greater visibility, software engineers can resolve issues faster, which has a direct effect on the time to market and reduce overall development cost. So advantage ಏನಂದ್ರೆ ಡಿಬಗ್ ಯೂನಿಟ್ ನ ಯೂಸ್ ಮಾಡೋದು. ಸೊ ಇಂಟರ್ನಲ್ ಡಿಬಗ್ ಯೂನಿಟ್ ಇರೋದ್ರಿಂದ ನಿಮ್ ಸಾಫ್ಟ್ವೇರ್ ಡಿಸೈನ್ ಟೈಮ್ ಏನಿದೆ ಅದು you can reduce that one. So you can quickly design the system. So you can quickly identify the faults in your system. So next, the ARM core is not a pure RISC architecture. So in order to balance the performance, power consumption, and the demand of a modern embedded system requirements, so they use the basic RISC concept. So they are not completely using that basic RISC concept. They have made some smaller changes to the basic RISC concept so that will provide the greater processing ability to the your ARM processor. So to strength of the ARM core is that it doesn't take the RISC concept too far, because today's systems, the key is not raw processor speed but total effective system performance and power consumption. So as I told that overall performance of your today's embedded system requirement is that the not only the speed, so it requires power consumption as well as the overall performance. So in order to meet these performance, they have made some changes to the basic RISC concept. So now we will see what are the changes they have made. So they have made some enhancement to the basic RISC feature. So first thing is that the variable cycle execution for a certain instruction. So it uses the basic RISC concept. Almost all the instructions are of fixed length and execute in a single cycle, but there are certain instructions they will take multiple cycle to execute. So not every ARM instruction execute in a single cycle. For example, load store multiple instruction vary in the number of execution cycle depending upon the number of register being transferred. So as I told that this ARM processor is a load store type of architecture which uses a separate load and stored instructions. So when you are using this load and store instruction, you can load the multiple registers and store the multiple register content in a single operation. So in that case, for storing the more than one register content to a memory, it requires more cycle. So like that, there are certain instructions, they will take more than one cycle to complete its operation. The transfer can occur on sequential memory address, which increases the performance since sequential memory access are often faster than random access. So code density is also improved since multiple register transfer are common operation at the start and end of the function. So while implementing the user defined functions, in that case, you have to take the arguments, and after execution of that instruction, you have to pass the arguments back to the called uh, called calling function or called function, like that. So in that case, in such for that operations, this load store instruction which take a multiple cycle, so that that will contribute to reduce the code density of your system. So next, another changes they have made to the basic ARM processor is that inline barrel shifter. So this is a special combinational shift register circuit, so that will execute in a single cycle. So leading to a more complex instructions. This inline barrel shifter, which leads to a more complex instruction. The inline barrel shifter is a hardware component that pre-processes one of the input register before it is used by an instruction. So this expands the capability of many instructions to improve core performance and code density. So inline barrel shifter is nothing but it is a shift register, so that will perform say left shift and right shift operations. So usually these shift registers are of sequential circuits, but here in this ARM processor they are using a barrel shifter which is designed using a combinational circuits. So you know that what is the difference between combinational circuits and the sequential circuit. Combinational circuits means they doesn't require any clock signals. So whereas sequential circuits, they require a clock signal. So they have a memory. So combinational circuits, they won't have any memory. So that means this inline barrel shifter is designed in such a way that it will pre-process one of the operand that is coming into the execution unit. So you can add this barrel shifter operation for all the instructions. So when I explain about the instruction set of this ARM processor, I will explain how actually this inline barrel shifter can be added to the all the instructions of ARM processor. So this concept will expand the capability of many instructions to improve more performance and code density. So another important point I have to remember with the ARM processor is that it has a secondary instruction set that is called as a thumb instruction set. So thumb 16-bit instruction set. ARM enhanced the processor core by adding a second 16-bit instruction set called thumb that permit the ARM code to execute 16-bit or a 32-bit instruction. The 16-bit instruction improve the code density by about 30% over 32-bit fixed length instructions. So when you are designing a system, your system system has a very less memory. In that case, you can use the 16-bit instruction because that occupy 30% less memory than that of the 32-bit instructions. So either you can use a 16-bit instruction or a 32-bit ARM instruction in your software design. So according to your system requirement. So in order to reduce the code density, they have provided the secondary instruction set in the ARM processor. That is called thumb instructions. Thumb instructions are of 16-bit length. So next important changes they have made to the basic or RISC system is that the conditional execution. Usually in CISC system, you will have a separate conditional instructions. But here in this ARM processor, you can add the conditional execution for almost all the instruction. So you have an add instruction, subtract instruction, and load stored instruction. For all these instruction, you can execute based on the conditions. Like if there is a carry, you can perform an addition operation. If there is no carry, you can skip the operation like that. So that condition can be added to the existing instruction. So without using another instruction. So that will lead to a high code density. So along with this, hello.
Hello.
Yes, sir.
Sir,
ಕೇಳಿಸ್ತಿದೆ.
ಸೊ ಇದನ್ನ ರೆಕಾರ್ಡ್ ಮಾಡಿದ್ದೀನಿ, ಆಮೇಲೆ ಅಪ್ಲೋಡ್ ಮಾಡ್ತೀನಿ. ಸೊ ಫಾಸ್ಟ್ ಅನ್ಸಿದ್ರೆ ಅದನ್ನ ವಿಡಿಯೋ ನೋಡ್ಕೊಳ್ಳಿ ಆಮೇಲೆ. ಸೊ ಬೇಸಿಕ್ ಫೀಚರ್ ಅಲ್ಲಿ ಚೇಂಜಸ್ ಮಾಡೋದು ಇಷ್ಟೇ. ಸೊ ಕಂಡೀಷನಲ್ ಎಕ್ಸಿಕ್ಯೂಷನ್ ಆಡ್ ಮಾಡಿದ್ದಾರೆ. ಎಲ್ಲ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ನೀವು ಕಂಡೀಷನ್ ಎಕ್ಸಿಕ್ಯೂಷನ್ ಆಡ್ ಮಾಡ್ಕೋಬಹುದು. ಆಡ್ ಆನ್ ನೋ ಕ್ಯಾರಿ, ಸಬ್ಟ್ರಾಕ್ಟ್ ಆನ್ ಕ್ಯಾರಿ, ಲೈಕ್ ದಟ್ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದ ನಿಮೋನಿಕ್ಸ್. ಸೊ ಯು ನೋ ನೀಡ್ ಟು ಯೂಸ್ ದ ಅಡಿಷನಲ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್. ಆಫ್ಟರ್ ಯೂಸಿಂಗ್ ಆಡ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಯು ಕ್ಯಾನ್ ಜಂಪ್ ಆನ್ ನೋ ಕ್ಯಾರಿ ಲೈಕ್ ದಟ್. So you can use the condition for the existing instruction. So this is the one important point of an ARM processor. So another thing is that they have an enhanced instruction set. So enhanced digital signal processing instructions were added to the standard ARM instruction set to support fast 16x16-bit multiplier operations and saturation. So this instruction allow faster performance ARM processor in some cases to replace the traditional combination of a processor plus DSP processor. So they have added to the additional instruction of this basic ARM processor instruction, so that you can perform the digital signal processing operations on the